Assalamualaikum warahmatullahi wabarakatuh. My name is Mohamad YIMTIYAZ, and today me and my group will present wireless network design for small company. So for the first slide, I will be talking about the introduction of this project. So wireless network allows users to stay connected to the network while roaming around freely. Unlike wired networks, there are a limitation of distance since it needs the help of cabling. Other than Wi-Fi, there are different types of wireless networks, such as ZigBee, Z-Wave, Bluetooth, LTE, 5G, and etc. Other than LAN, there are also different wireless connections, such as PAN, MAN, and WAN. So in this project, it will help us to create a wireless network design followed by the company's requirements. So next, we'll be talking about the problem statement of this project. So the problem statement is a small company requires a wireless network design for their company. The company is set on a 3-story building with a variety of departments and require wireless networking on each floor to work with. So, next slide. Next, I'll be talking about the objectives of this project. So there are 3 objectives that we want to achieve for this project. The first one is to design a working wireless network for the small company. Second is to provide an analysis of the wireless networks. And last but not least, to identify and describe 3 wireless standards that play a role in the network. So next is the project significance. The significance of this study is to implement the knowledge that students have learned into this project, which is to design a wireless network for a small company with the appropriate methods. Analysis of the wireless network design must be made and must address all the appropriate information, as this study will improve the wireless network system of the company.
Hello, my name is NATASHA. So I will be explaining chapter 2, which is literature review. So what is WLAN technology? WLAN is to provide LAN access to portable and mobile stations, such as laptop, computers, voice headsets, barcode readers, etc. WLANs use radio links to transmit data, and as with any radio communication system, they are susceptible to the radio frequency propagation and interference problem. So, as we can see on the slide, the table show the differences between wired and wireless LAN. So, wired LAN wired LANs use CSMA and or CD as their MAC protocol. Meanwhile, while wireless LAN use CSMA slash also CA as their MAC protocol, and wired LANs throughout the usage is throughout the enterprise, while wireless LANs access links to wired infrastructure. And devices that can be connected to wired LANs is computers, switches, and routers, while wireless LANs, computers, switches, laptops, personal digital assistant, phones, barcode scanners, and RFID tags. And the interference for wired LANs nearly non-existent, while for wireless LANs highly susceptible. Implementation complexity for wired LANs is relatively low, meanwhile wireless LANs is highly complex. So next is WLAN hardware. First is access point. It is a networking device called a wireless access point, enables wirelessly capable devices to connect to a wired network. And second is router. Router use packets which can carry a variety of data types, including files, messages, and straightforward broadcasts like internet activities. And next is network switches. In the open system interconnection (OSI) architecture, layer 2's data link layer is where a network switch physically operates. It receives packets sent by devices connected to its physical ports and send them to the targets of the packets. And lastly, we have wireless repeater. A wireless repeater is a type of network equipment used to transmit wireless network signals past the conventional network boundary. So, this is the network requirement for our project. First, ground floor, as we can see in the table, this is the ground floor network requirement. And second is floor 1 network requirement. And third is floor 2 network requirement. So the thing that we discussed is the signal strength should be at least 70 dBm and signal to noise ratio at least 15.0, data rate at least 6 Mbps, and number of access point at least 4. Ping around round trip time at most 200 ms, and packet loss at most is 5%. So the number of access point is different for each floor. So for the ground floor, we use 4 access point, and for the first floor, we use 2, and lastly for the second floor, we use 4 access point at least. So this is the capacity of the devices for each floor. So as we can see in the table, for ground floor, we use 26 laptops, 10 smartphones, and 5 tablets, and it is total 41 devices. And for the first floor, we use 9 laptops, 9 smartphones, and 3 tablets, and the total is 21 devices. And for the second floor, we use 25 laptops, 20 smartphones, and 8 tablets, which total 53 devices. So that's all from me. Thank you.
Assalamualaikum, my name is NURUL MOHAMAD SHARIFUDDin, and I will present for the chapter 3 WLAN design. So here is the floor map of the building. So first is the ground floor, second is the floor 1 and floor 2. So as you can see, there is 4 AP for the ground floor. For the first floor, there is 2 AP. And for the second floor, there is also 4 AP. So here is the logical network diagram for the company. Here we show the full topology network diagram. So first is the internet, and then the telco router, implement the firewall, and then the switch, and it will be connected to each of the floor in the building. So here is the ground floor, first floor, and the second floor. So here is the ground floor topology, first floor topology, and the second floor topology. So it shows that how the wireless network connected to the end devices such as smartphone, laptop, tablet, and all. So lastly, the special request and consideration. So for this project, there are several things that we consider adding to this network design. First, include a firewall to enhance the security of the network. Second, as for the thing that can be considered in the future is to add more layer 3 switches to act as a backup in case that there was a network failure or downtime for the main switch. And then, VPN should be applied by the company into the network. This will help the company to have more secure connection to access to the company resources. And lastly, implement the wireless LAN controller WLC because it can lessen the difficulty of administering large-scale wireless network while also enhance the network performance, security, and dependability.
So next, I will be presenting the result and analysis for this project. So the first thing that we analyze is the signal strength and coverage. The figure below shows the signal strength and coverage for the whole building with each floor, with the signal strength for each access points to reach the devices. AP is a device that creates a wireless LAN that is used in the office or building. By referring to the figure below, there are areas with red highlights that shows that the area is not covered for the range of the AP installation for that area. It shows that AP also has its own limits to cover all the area in the floor, but it can cover much of it as seen in the green highlight in the figure. So next is an analysis of SNR. SNR is a ratio of signal power to noise power, and its units of expression is typically decibels. It will measure the strength of the desired signal relative to the background noise, which is an undesired signal. It is also imperative to distinguish various output signals to achieve efficient output. A higher SNR value means the signal is more clear. A good SNR is 20 dB or above, that has signal levels much higher than noise levels. The greater the noise level, the more disruption will be caused when the level of background noise is more than it should be. It means that the ratio is low signal to noise. In the figure, we can see that the signal strength near the access point have the green color, shows that the signal is more clear, and moving far away from it, we can see the color starts turning red, shows that the signal have greater noise and disruption happen. So next, we analyze the packet loss. Packet loss occurs when data packets transmitted over a network fail to reach their intended destination. This can happen for a variety of reasons, including network congestion, transmission mistakes, or network failure. Packet loss can have a substantial impact on network application performance, resulting in delays, lost data, and poor quality in real-time communication, such as video conferencing. So as you can see for this project, all of the results show that packet loss is 0%. So it means that we can see that there are no packet loss that occur during the testing, showing that the implemented network is performing well. How do we test the packet loss? Is by ping from the PC to another network, to another PC from other floor. So next, we analyze the latency. Latency is the time it takes for a data packet to get from its source to its destination across a network. It is usually measured in milliseconds and indicates the time elapsed between when a packet is delivered and when it is received. High latency can create network application slowdown or delays, particularly in real-time communication, gaming, and online transaction, making them less responsive and usable. In most applications, low latency is desired to ensure good quality and pleasant experience. So for this project, in this testing, we can see that the latency value does not exceed 100 milliseconds. This means that the connection is considered to be excellent because latency value that is below 100 milliseconds is desired for office day-to-day activities such as file sharing, video conferencing, and web browsing. So the last thing that we analyze is network jitter. Network jitter is the variation in the arrival time of data packets through a network. Jitter monitors the fluctuation in time taken for a packet to travel from source to destination. An acceptable jitter value is ranged from 0 to 30. So for the ground floor, the jitter that we calculated is 7 ms. So the first floor is 9 milliseconds, and for the second floor is 12 milliseconds. All of the jitter that we calculated does not exceed 30. So this means that our network is good enough.
Alright, now we arrive at the recommendations of the project. So there are a few recommendations that could be made for future work on newly made wireless network design, such as implement network security, which can protect the company from getting any malicious threat and will prevent any future threats. An example of malicious threat that we're talking about will be DDoS attack, viruses, phishing, ransomware, and many more. Other than that, perform maintenance frequently will be essential to keep the network perform at maximum efficiency. It will be much easier to troubleshoot when any problem occurs and any risking damage to both software and hardware devices over time. So next is the conclusion of the project. So in conclusion, this wireless network design is suitable for a small-scale cooperation based on the essential criteria for the cooperation. The logical network design is required for proper information exchange between network and system administrators, and each floor has been designed to suit specific requirements to increase the WLAN design's efficiency and effectiveness. Signal to noise ratio and signal strength had to be examined to ensure that a steady connection could be formed. And finally, this project, we gained lots of information about wireless network. That's all from our group. I hope this presentation will be beneficial to anyone who watches it. That's all from us. Thank you.